Welcome to today's deep dive. Today we are exploring this backyard ecosystem that basically became a complete total mystery to its caretaker.
Right?
And we're going to look at how a delightfully simple solution just completely changed everything.
It really is a great story.
Yeah, our mission today is to extract a really fascinating micro story from a source we've been digging into. We're looking at a journal entry from a very long-running series. It's called Notes on Fishkeeping, specifically part 256.
Wow.
Yeah, authored by a caretaker named Ang, and the piece is titled Beneath the Surface, The Mesh Basket Revival, which was published on May 15th, 2026.
Hitting part 256 of any observational journal it's a massive milestone.
Oh, absolutely.
It tells you right away that we are dealing with a caretaker who has been observing aquatic systems for a long, long time.
Right, which I think makes the central conflict of this entry so compelling because, when you build a machine, say like a custom computer, you know exactly what's in there. You bought the processor, you plugged in the memory, you screwed on that clear glass side panel. You can literally watch the LED lights blink and just know the whole system is working. You put data in, you get data out.
Well, yeah, because it's a completely deterministic system. The inputs and outputs are visible, they're measurable, and highly controlled.
Right. But then you step into the world of biology,
Right.
specifically trying to curate your own outdoor ecosystem. And
Yeah.
suddenly, it's like someone has just painted over that glass side panel. You know what you put into the water, but you have absolutely no idea what's actually happening inside. And that tension between what we introduce to a habitat and what actually survives in there, that is the core of Ang's journal entry.
Yeah.
So we're going to see how a ridiculously low-tech backyard hack can basically bypass an impenetrable biological wall.
What's fascinating here is how this story illustrates a much broader truth about observation.
Mm-hmm.
Sometimes in the most complex, totally unpredictable ecosystems require the absolute most low-tech interventions for us to actually understand them.
Yeah, we tend to really overcomplicate things.
We do. We
Yeah.
overcomplicate our solutions when nature gets complicated. But Ang leans in the complete opposite direction here.
Totally. So to understand why an intervention was even necessary in the first place, we have to look at the environment Ang is actually managing.
Right, the setup.
Exactly. The setting is a series of outdoor ponds, and the weather plays a huge role here. The journal specifically notes that these ponds have just endured a few days of heavy downpour.
Oh, wow.
Just relentless, driving rain. And if you manage an outdoor pond, you know that a severe downpour isn't just water falling from the sky. It's a massive disruptive event.
Right, it's a full-scale environmental shock. I mean, you are looking at rapid temperature drops, wild fluctuations in pH levels,
Yeah.
and intense turbidity as all this dirt and debris are just churned up into the water column.
Which has to be awful for the fish.
Ooh, the osmotic stress on the fish could be
Yeah.
severe. So when the journal notes that the weather has finally turned pleasantly sunny, that shift is crucial. The sun returning is what prompts Ang's anxiety and the desire to just go out and assess the aftermath of this huge storm.
Right, but the problem is, when Aang actually goes out to look, there is a massive visual roadblock.
Yeah, the surface.
The water's surface is heavily crowded.
Yep.
It is totally covered by a bushy aquatic plant that Aang identifies as common salvinia.
Right, and common salvinia isn't just some plant that floats harmlessly on the surface.
Okay.
It is a highly aggressive, really fast-growing fern. It has these modified, feathery fronds that dangle beneath the surface, acting as roots.
Oh, interesting.
Yeah, and while those are underneath, the top leaves are covered in these hydrophobic hairs that literally repel water.
Oh, wow. So it just sits right on top, perfectly dry.
Exactly. And it multiplies so rapidly that it forms dense interlocking mats.
Right.
Biologically, I mean, it's an absolute powerhouse. It acts as a massive nutrient sponge, pulling heavy metals and excess nitrogen directly out of the water column.
Which I'm guessing is a good thing.
Oh, very good. It basically prevents toxic algae blooms. But the trade-off is that it creates a literal, impenetrable green roof over the entire pond.
Yeah.
It blocks out the light, and of course, it completely blocks out the human eye.
A green roof that completely hides a mystery that has been just eating at Aang. Because here is the core issue, right? Aang has, over time, introduced several different varieties of guppies into these outdoor ponds.
Yes.
But because of this interlocking salvinia roof, Aang has absolutely no idea if these guppies actually acclimated to the water, or honestly, if they even survived the initial move.
And that uncertainty is really heavily compounded by a very specific, highly localized threat lurking right beneath that green roof.
The cichlids.
Yes, the cichlids.
Eng notes that there is an existing, established cichlid population in these ponds. Now, for anyone familiar with aquatic ecosystems, cichlids are notoriously aggressive, right?
Yeah, very territorial.
They are intelligent ambush predators, and Eng flat out suspects that they might have simply treated the newcomer guppies as an expensive live-action snack.
I mean, it's a highly probable scenario. Cichlids possess a really highly developed lateral line system.
Okay, what does that mean?
Basically, they can sense the microscopic vibrations of smaller fish moving through the water column.
Oh, wow. So they don't even need to see them.
Exactly. They stalk from below and just strike upward. So when you introduce small, highly vulnerable newcomers into an established cichlid territory, you are basically initiating a high-stakes biological conflict.
Okay, let's unpack this. Because I have to admit, when I was first reading through this source, I found myself seriously questioning Eng's methodology here.
Really?
How so? Well, we are talking about someone on their 256th journal entry. Why on earth would a seasoned fish keeper keep adding these tiny guppies into a literal black box where a known highly efficient predator lives?
I see.
It feels careless. It's like setting up a classic locked room mystery where the victims just keep walking into a room, the door locks behind them, and they vanish into the bushy salvinia. You know the killer is in there. Why keep sending in victims?
Well, I'd actually pushed back on the idea that it's careless.
Yeah.
Yet you have to view this through the lens of ecological balancing rather than just simple pet keeping.
Okay, fair enough.
This is the ultimate struggle of managing a living system. Look, a display aquarium in a living room is sterile. It exists purely for the human viewing experience.
Right, it's pretty.
Exactly. But Aang isn't trying to build a display case. Aang is trying to build a biological engine. And biological engines are inherently messy, they're competitive, and honestly, they're inherently violent.
So the goal isn't just to keep every single fish alive indefinitely.
No, not at all. The goal is to establish a diverse, self-sustaining population that regulates itself over time.
Got it.
Introducing different varieties of guppies over time is just an attempt to build genetic diversity and establish a prey-predator equilibrium. The dense salvinia isn't some landscaping mistake. It is a deliberate structural part of the habitat. It provides the necessary cover for a complex food web to exist. The friction arises because the very thing that makes the ecosystem stable, the dense plant cover, is what locks the human caretaker out of the feedback loop.
Which creates an agonizing catch-22 for Aang.
Exactly.
Because if you want to know if your guppies are surviving, your first instinct is to clear the view.
Sure.
But if you strip away all that common salvinia so you can see every corner of the pond, you instantly destroy the ecosystem's filtration system. And more importantly, you remove all the hiding spots.
Exactly. The moment you pull that green roof back to take a look, you completely expose the guppies to the open water.
Yeah.
The cichlids wouldn't even have to hunt at that point. It would just be a buffet.
Right.
The ecosystem would literally collapse under the weight of the human need to observe it. It's a biological observer effect. The very act of measuring the system destroys the system.
Wow.
So the caretaker really needs a clever workaround, a way to solve the locked room mystery without actually tearing the room apart.
Which brings us to the search for a solution. Aang wants to peer into this murky post-storm pond, but knows they can't just rip all the common salvinia out.
Right.
So Aang goes digging. The journal states they were digging through old fish accessories that have been kept in storage for moons.
That specific phrasing, for moons, is such a great detail.
It is.
Because anyone who has ever been deep into a hobby knows the harsh reality of the storage bin.
Oh, absolutely.
You accumulate specialized gear that just sits in a dark garage for years, waiting for some hyper-specific use case to justify keeping it.
And what Aang rediscovers in this pile of forgotten gear is honestly impressively mundane. It's literally a plastic mesh basket.
Yeah, we should probably establish the context of what a plastic mesh basket is actually engineered to do in this field.
Good point.
Because understanding its intended design makes Aang's localized hack just brilliant.
Right, so typically you're using it as a nursery or like a containment zone. You want to keep a breeding pair separated, or more likely, you are trying to keep the fry completely separated from the adults who would otherwise, eat them.
Precisely. In standard aquaculture, a mesh basket is just a porous cage. It is designed to be suspended right in the water column.
Right.
The mesh allows the oxygenated water to flow through freely, which maintains the temperature and the chemical balance. But the rigid plastic walls keep the aggressive adult fish out, and the vulnerable fry are trapped safely inside.
Okay.
Its entire architectural purpose is containment. It traps life inside a designated safe zone.
Well, here's where it gets really interesting, because Aang looks at this tool and completely reverses its intended purpose.
Yeah.
Aang does not use it as a cage. Instead of using the basket to trap fish in, Aang uses it to keep the aquatic plants out.
It's a total subversion of the tool's original utility.
It really is. Picture the mechanics of this. You have this dense, thick carpet of bushy salvinia covering the entire surface of the pond. Aang takes this empty plastic mesh basket, floats it right on the surface of the water, and uses the rigid sides to literally push back the floating plants.
Mm-hmm.
The mesh walls of the basket hold the bushy salvinia at bay, but because it's mesh, the water inside the basket is the exact same water as the rest of the pond.
Exactly.
It creates this perfectly clear, localized circle of water right in the middle of the overgrown jungle. It's a dedicated viewing and feeding area. It's like, imagine you are hovering in a helicopter over an impenetrable rainforest canopy, and you just drop a massive glass-bottom boat directly into the leaves.
I love that analogy.
Right. Suddenly you have a window to the forest floor.
Well, and if we connect this to the bigger picture, think about the psychological shift that occurs the exact moment that basket hits the water.
Yeah.
By repurposing this forgotten, really mundane piece of plastic, something stored away for moons, Aang instantly transitions the caretaker's mindset.
Right.
You move from a state of blind, anxious theorizing to a state of direct empirical observation.
Yeah, moving from, I really hope those cichlids didn't eat them, to, okay, let's actually gather some data.
And crucially, it is a non-destructive intervention.
Right, no pulling plants out.
Exactly. It requires no electricity, no chemical water clearers that might, shock the fish, and no physical disruption of the roots.
Wow.
Aang respects the boundaries of the habitat while simultaneously satisfying the human need for visibility. It just leverages the surface tension of the water and the buoyancy of the plastic to physically part the curtain without damaging the stage.
Which brings us to the payoff. So, the heavy rains have passed, the weather is sunny, and this new non-destructive window is installed. We have this clear viewing area actively pushing back the salvinia. The stage is set.
It is.
What does this simple plastic basket finally reveal?
Well, the feedback is immediate, which honestly is quite rare in biology.
Right. Usually you have to wait.
Usually, yeah, you are waiting weeks to see if an intervention worked.
But here, almost right after installing the basket and dropping some food into that clear circle, the mystery of the black box pond is completely solved. Aang looks down into the water and spots a new spawn of guppies.
Yes.
Baby guppies, alive and swimming.
But, the most critical piece of data here is exactly where those fry are spotted.
Oh, right.
The journal entry explicitly notes that these new guppies are seen directly emerging from the bushy aquatic plant, the common salvinia.
They are swimming right out of the very thing that was blocking Aang's view.
Exactly.
The conclusion is just undeniable. The guppies didn't just survive the shock of being moved to the outdoor pond. They didn't just evade the highly aggressive cichlid population. They fully acclimated to the environment, they established territory, and they successfully reproduce.
Biologically speaking, you really have to look at how they achieved that. Remember those dangling, feathery fronds of the salvinia we discussed earlier?
Yeah, the roots.
Right. Well, they aren't just roots. They form a complex, microscopic labyrinth. Those roots harbor infusoria, which are microscopic organisms that serve as the absolutely perfect first food for newly hatched fry.
Oh, wow. So it's a food source, too.
Yes. And more importantly, those dense root structures act as an impenetrable physical barrier against the larger cichlids.
Ah, because the cichlids are too big to get in there.
That and the cichlids' lateral line system, which they use to hunt.
Right, the vibration sensing.
Exactly. It gets completely overloaded by the physical presence of the roots. The vibrations are dampened, so the guppies survived, precisely because they utilized the architecture of the pond.
So what does this all mean? Because when I read that specific detail, that the fry emerged from the bushy salvinia, the entire narrative just clicked for me.
Right.
The irony is staggering. The very thing that was frustrating there, this dense, bushy plant cover that made the ecosystem opaque and generated all this anxiety about the cichlids, that plant was the exact shield the guppies used to hide from the predators and actually thrive.
It forces us to entirely reevaluate what we consider an obstacle.
Yeah.
The obstacle to the observer was the absolute lifeline for the observed.
It's wild to think about. Had Aang given into that initial anxiety, had they taken a net and scooped out all the salvinia just to check on the fish, Aang would have actively destroyed the only mechanism keeping those guppies alive.
Which is why this raises an important question, one that I think any manager of a complex system, whether it's the cichlids were patrolling their territory.
Ugh.
The salvinia was regulating the nitrogen cycle and keeping the water clean. The biological engine was a massive success long before Aang ever went digging through storage for that mesh basket.
Wow, yeah.
The simple adjustment of adding the basket was, as Aang wrote, a welcome change. But biologically speaking, it was a welcome change purely for the human's peace of mind.
That is a wild realization. The pond didn't need the basket to function. Aang needed the basket to cope with the ambiguity of the pond.
It highlights a massive cognitive bias we all share. We have this intense, deeply ingrained belief that if we cannot actively see a process working, it must be failing.
Yes.
It's basically a biological version of Schrödinger's cat, or Schrödinger's guppy in this case.
Schrödinger's guppy, I love that.
We assume the guppies are dead simply because we can't see them swimming. But nature doesn't require an audience to thrive.
That is so true. We constantly equate our own anxiety about a lack of data with the actual objective health of the situation.
Exactly. We project our need for control onto systems that are naturally self-regulating. Aang's genius in journal entry 256 wasn't in fixing a broken pond.
Because the pond was never broken.
Right. The pond was never broken. Aang's genius was recognizing that the human observer was the one who was stressed and figuring out a way to fix the viewing angle without disrupting the system's delicate equilibrium.
That is such a fantastic, layered takeaway. So let's wrap up the journey we've been on today.
Okay.
We started with an obscured, rain-soaked outdoor ecosystem. A caretaker is standing on the edge, looking at an impenetrable green roof of common salvinia, totally burdened with the heavy anxiety of a potential predator problem.
Right. The aggressive cichlids versus the unseen, highly vulnerable guppies.
A literal black box where the inputs are known, but the outputs are completely hidden beneath the surface.
Yeah.
And then the weather breaks, the sun comes out, a mundane piece of plastic mesh forgotten in a storage bin for moons is dragged out and repurposed. It's transformed from a tool designed to trap life inside a cage into a window designed to push barriers away. And through that simple, non-destructive, totally low-tech window, we get a sunny revelation of new life.
Exactly.
The very barrier that caused the caretaker's anxiety was the biological shield that allowed the new generation to flourish.
It's a perfect micro story about the restraint required in observation.
It really is. And for you listening, the value of this lesson extends so far beyond the niche world of fish keeping.
Absolutely.
The major takeaway here is that sometimes you do not need to tear apart an entire system just to understand it. When things are murky, when a project at work, a team dynamic, or honestly even a relationship feels like an opaque black box, your first instinct shouldn't be to rip out all the vegetation to see what's going on underneath.
Right, because you might accidentally destroy the very framework that is keeping the system stable.
Exactly. Sometimes you just need to clear a small, localized viewing window.
And that leads me to a final thought I'd really like to leave you to mull over. We've seen how a simple repurposed plastic mesh basket can reveal a thriving hidden world of new life in an overgrown pond. So, what metaphorical mesh basket could you install in the overgrown, chaotic, or opaque areas of your own life or work?
Oh, I like that.
What small, highly localized, non-destructive window could you create to finally see the progress that is secretly surviving, and perhaps even thriving, right beneath the surface?
We started today talking about custom computers, about the absolute comfort of that clear glass side panel where you can see every blinking LED light and know exactly how the machine is running.
Right.
Life, biology, and human systems rarely give us that clean glass panel. But what Aang showed us today is that you don't need a perfectly clear, sterile glass case to know a complex system is working. You just need to know how to gently peek through the leaves. Thanks for diving deep with us today.